In this video, we're going to be learning about polynomials. This video will be helpful to students that want to learn about math and also do some research on programming as well. We will first go over all the math basics needed to learn this topic, then at the end of this video, we're going to be enhancing our knowledge with programming inside of Python. So just before we get into learning about polynomials, let's first watch this Missile launch clip. So after watching this clip, you can see that the path of the projectile looks like a polynomial equation. So at the end of this video, we're also going to be plotting this polynomial with Python. So throughout this video, we're going to be covering the following topics. We will first go over what a polynomial is. Second, we're going to go over what terms and degrees are. Third, we're going to go over the classification of polynomials. Fourth, we're going to look at degrees of polynomials. Fifth, we'll look at the simplification of polynomials. Sixth, we'll look at addition and subtraction of polynomials. And seventh, we're going to be going over our Python code. So let's get started with what a polynomial is. So a polynomial is basically just an algebraic equation made up of terms connected by the operation of addition or subtraction. An example of a polynomial could be 3x to the power of 2 minus 4x plus 1. So that is a polynomial. So just before we dive deep into polynomials, we first need to understand what a term and a degree is. So let's first look at what terms are. So a term is an expression that is formed by the product of numbers and or variables. So for example, 3x squared minus 4 plus 1. And this is an expression. And in this expression, there are three terms. The first term is 3x squared, the second one is minus 4x, and the third one is plus 1. So all terms have two parts. And those two parts are, as we said before, the number and the variable. And even if one of the terms have just a constant, like for example just plus 5 or plus 1 in this example, then you could also add the variable yourself as x to the power of 0, which will still give it the variable number, because any number to the power of 0 is 1, and 1 times the number is always that same number. So every term always has a number and a variable part to it. And the coefficient in any term is any number. It could be a decimal number such as 1.4, it could be a whole number like 5, or it could also be a fractional number such as 1 over 3. But now for the variable part, it can get a little bit more complicated. A term can be made up of one or more variables. So we could have x squared, which is just one variable. We could have just y. We could also have x squared and y squared. So then there we have two variables. We could have ab squared, c cubed as well. So there we have three variables. So in one term, you can have a lot of variables inside of it. And the common way to write terms is by putting the coefficient first and the variable after the coefficient. A lot of people sometimes put the variable first, which is wrong. So for example, it would be 6y and not y6. So now that we know a little bit of what polynomials are, let's look at the classification of polynomials. So a polynomial has two syllables, which is poly plus nomial. And poly means many and nomial means terms. And a polynomial may have one term, it may have two terms, three terms, or even more than that. It can go as much as it wants. And there are also special names given to a specific amount of terms. For example, a polynomial with one term could also be called a monomial. A polynomial with two terms could also be called a binomial. A polynomial with three terms could also be called a trinomial. And four or more could just be called polynomials. And a common misconception between people is that they think that only more than three terms is called a polynomial, but that's incorrect. All expressions have one or more terms which could also be called a polynomial. They just also have specific names as well. So even if a polynomial has two terms, you could still call it a polynomial, or you could also even call it a binomial as well. So let's look at some examples of monomials. So we already know that monomials have one term, so a one term would look like just 7, which would just be a constant there, or we have 4x, or it could also be 3ab to the power of 3, so just having one term. So now let's look at examples of binomials. So we already know that binomials have two terms, so for example 4 plus x, or 3xy plus y, or 3ab cubed plus c. So it just has two terms, and it's separated by either subtraction or addition. So now let's look at trinomials. So a trinomial has 3 terms, and for example, it could be 4 plus x plus y, or 3xy plus y plus 8, or 3x plus y squared plus 30. So it has 3 terms. So a polynomial has more than 3 terms. So for example, it could be 4x cubed plus 3xy plus 3y plus 1. And also, just as we said before, the polynomials could be said with 1 or more terms. So that's it for the classification of polynomials. So now let's go over what a degree of a polynomial is. So a degree of a polynomial is basically the sum of all the exponents from all of the variables in a single term. So for example, if we have 3x squared, so in this term we have 2 degrees because we have the exponent of 2. So we would have 2 degrees here. And let's take another example, for example, negative 4x, and here we'd have 1 degree because x is we always have the exponent of 1 at the top, so we have 1 degree there. And here's another example, which is 2y 3x, and here we would have 2 degrees because y and x both have the exponent of 1, so we can just add 1 plus 1, which is 2 degrees. And inside of a polynomial, we always take the highest degree among each term. So if we have 4x to the power of 3 plus 3xy plus 3y plus 1, we would obviously take the first term because it has the highest degree among each of the terms, hence the degree of this polynomial is 3. So if we look in the first term, we see 4x to the power of 3, which is the degree of 3. And then we have plus 3xy, and we know that's going to be 2 because we can do 1 plus 1, which is 2. And then we have plus 3y, which would be 1 because we have one variable. And then we have plus 1, and we always know that a constant is going to have 0 because we could just do we could just do 1x to the power of 0, which would just still be 1. So here's another example of a degree in a polynomial. So if we have 8x to the power of 3 and y to the power of 2, then we're going to have a 5th degree term because we can just add 3 plus 2, which is equal to 5. So that's basically it for the degrees of polynomials. So now let's go over to the simplification of polynomials. So all polynomials have arranged terms, and this arranged terms are from highest to lowest. So let's take an example. So let's say we have 1 plus 3xy plus 4x to the power of 3 plus 3y. So to arrange this from highest to lowest, we first have to look at the degree of the polynomial and then order it from the highest to the least. So let's look at the highest one here, and we can see that it is 4x to the power of 3 because it already has the exponent of 3, and that is the highest by all of these terms here. So we're first going to put in the 4x to the power of 3 in the beginning. Then next, we can see that 3xy is going to be the next one because there's a second degree there, because we have x, which is 1, and also we have y, which is also 1, so we can add them. So then that's going to be 2. So we're going to bring that to the second. So next we're going to add in 3y because that has an exponent of 1. And finally we're going to bring in the 1 because it has an exponent of 0. So now our polynomial looks like this. We have 4x to the power of 3 plus 3xy plus 3y plus 1. And we just like to do this because mathematicians like to keep everything organized. And polynomials also have standard equations, and we list everything from highest exponent to the lowest. So for example, we always have to keep it from the highest exponent to the lowest. So for example, we have this: 1x to the power of 4 plus 1x to the power of 3 plus 1x to the power of 2 plus 1x to the power of 1 and also 1x to the power of 0. So all the degrees are in order from the highest to the lowest. So here's another example of arranging polynomials. So here we have x to the power of 3 plus 3x to the power of 4 plus 5 plus x plus 4 to the power of 2. So in this polynomial, we're going to have to order them from greatest to least because it didn't do it for us already. So we first have to look for the biggest term here, and we can see that it's going to be 3x to the power of 4 because it has the greatest number there, the greatest exponent there. So we're going to bring 3x to the power of 4 first, and next we're going to bring in x to the power of 3, and we can know this because that's going to be the second highest because it has the exponent of 3, so we're going to bring in that. So next we're going to bring in 4x to the power of 2, and then next we're going to bring in x, and then finally we're going to bring in 5 because it has the exponent of 0. And now if you look at our polynomial, you can see that everything is arranged from greatest to least, and it's also in sequence. All of the exponents are in sequence as well. We go from 4 to 3 to 2, then 1, and to 0. And we can also simplify our polynomials by combining the like terms. So for example, if we have 1x to the power of 4 plus 1x to the power of 3 plus 1x to the power of 3 plus 1x to the power of 2 plus 1x to the power of 1 plus 1x to the power of 0. So in this polynomial, we see that 1x to the power of 3 plus 1x to the power of 3 are like terms, so we can just add those two together. And if we add them, we're just going to have 2x to the power of 3. So this way, it just makes our polynomial easy to solve. And here's another example of combining the like terms. So if we have 2x plus 3x, we can obviously add those two together because 2x plus 3x are the same thing. They have the same variable at the end, which would make 5x. And here's not an example of what like terms are. So for example, if we had 4x to the power of 2 plus 6x to the power of 3. So we're not going to be able to add these because in the 4x to the power of 2, we have the exponent of 2. And on the other side, we have 6x to the power of 3. And we can't add that because they have x to the power of 3 and x to the power of 2. If they were both x to the power of 2, then we could add 6 plus 4. Or if they were both x to the power of 3, then we could just add 6 plus 4 again. But in this case, they're different, so we cannot add these. And also, to simplify our polynomials, we can also add missing terms. And we also do this from highest to lowest. And to do this, we just add the 0 coefficient. So for example, if we had our polynomial of 4x to the power of 5 plus 8 minus 10x. So in this polynomial, we can see that it's not in order because we have missing terms here because we need the exponent of 4 there, we need the exponent of 3, and the exponent of 2, which are not supplied here. So we're going to have to add them ourselves. And to do this, what we're going to do is we're going to add the coefficients of 0 to the power of each of the ones that are missing. So for example, in here, now we're going to do, we already have 4x to the power of 5, so which is going to be our highest. Then we're going to do plus 0x to the power of 4. So we're basically filling in the blanks there. And then we're going to do plus again, 0x to the power of 3 plus 0x to the power of 2 minus 10x plus 8. So now we have everything in sequence. We have the 5th power, then we have the 4th power, then we have the 3rd power, we have the 2nd power, we have the 1st power, and we have the 0th power. So this way, we can also simplify our polynomials by filling in the blanks by adding the coefficients of 0. So now we're going to be going over adding and subtraction of polynomials. So here's an example of adding polynomials. Let's say we have in bracket 5x to the power of 2 plus 8x minus 3, and then close the bracket, plus, open a new bracket, 2x to the power of 2 minus 7x plus 13x, and close the bracket. So here, what we're first going to want to do is remove the bracket, obviously. And to do that, we just remove the brackets. It's just as simple as that. And now our equation looks like this. 5x to the power of 2 plus 8x minus 3 plus 2x to the power of 2 minus 7x plus 13x. So now what we're going to do is we're going to add our like terms. So if we remember from simplifying, we always have to add our like terms, and then we also have to put them in order as well. So first, let's just add our like terms. We're first going to add the greatest like term, and that one is for the x squared. So there's a few x squareds here. There's 2x squareds here, so we're just going to add those two together. And the 2x squareds here are 5x squared and 2x squared. So in front of the 2x squared, we have the addition symbol, so we can just add 5x squared plus 2x squared. And that will give us 7x squared, and we can bring that to the front of the next line. And then next, we're going to add just our x, because there's a few of them. We have 8x and minus 7x, and also 13x as well. So what we're first going to do is we're going to do 8x minus 7x, and then we're going to do plus 13x. And in conclusion, that'll give us plus 14x. So then after that, we're going to bring that 14x behind the 7x squared. And then we have one more, which is our constant. And our constant here is minus 3. And since there's no other constant here, we can just bring the minus 3 down. So now our simplified equation of this polynomial is 7x squared plus 14x minus 3. So in this way, we can make our addition and subtraction for our polynomials way easier. So now for the same thing, but now we're going to be subtracting our polynomials. So here, let's open up our bracket again, and let's do 16x plus 14, close the bracket off, minus, open the bracket again, 3x squared plus x minus 9, and close the bracket. So what we first have to do is remove the bracket, so we just remove them. Now our equation looks like this: 16x plus 14 minus 3x squared plus x plus 9. So what we're first going to do is we're going to look at our greatest exponent here, and we can see that it's 2. So we're first going to see if we have like terms for that, and we can see that we don't have anything else that is to the power of 2. So we can just bring negative 3x to the power of 2 down. So then our first number would be negative 3x. The next, we're going to have to add up our x here. So we're going to have x because that's to the power of 1 and nothing else is to the power of 1. And if we do 16x minus x, we basically minus x is equal to 1x. So we can just do 16x minus 1x, which would give us 15x. So we're going to bring down plus 15x. So now our equation looks like negative 3x to the power of 2 plus 15x. And finally, we're just going to add up our constants, which is 14 plus 9, which gives us 23. So now our equation looks like negative 3x to the power of 2 plus 15x plus 23. So this is basically how you simplify subtraction and addition for polynomials. And that's basically it for the beginning part of this video. And next we're going to be moving on to our Python code. So now we're going to be moving on to our Python part. So I have 2 codes saved for us today. Our first one will help us to generate a polynomial in standard form by just making an array of numbers. And second, we're going to be plotting polynomials on a graph in Python to also match our Missle projections. So let's move on with our first code here. So this first code is very simple here. It's just 3 lines of code, and I'm just going to explain what each of it does, and you guys can copy it down from your own computer. So first, we're just going to be importing numpy as np. So this will just help us for transferring these numbers into actually making a polynomial. So next, we're just going to be creating a variable called numbers, and we're going to assign an array of 1, 2, 3, 4, and 5. So the Python program is going to first see that there's 5 numbers here. Then it's going to put exponents on each one of them from greatest to least. So this one should be exponent of 4, this one should be exponent of 3, this one should be exponent of 2, this one should be exponent of 1, and this one should be exponent of 0. And it automatically will also put a variable for us as well. So it'll basically be 1x to the power of 4, 2x to the power of 3, and so on here. And next we're just going to be printing np.poly1d, which is polynomial 1 dimension, and inside of there we're just going to be printing out our numbers. So technically, as I just explained, this should print out our polynomial for these numbers here. So let's just run this code here and see what we get. So if we open the side menu here, we can see that we got our successful code. As we said, we got our polynomial here. So we got, first we have 1x to the power of 4, then we have plus 2x to the power of 3, plus 3x to the power of 2, plus just 4x. It didn't write the power to the 1 here, it just wrote it as 4x, which is pretty smart. And also it just did plus 5, it didn't put 5x to the power of 0. So this is basically what this does here, and we can arrange it for any single polynomial that we want. And we can take an example from what we did earlier today. So if we remember from arranging our polynomials, we're going to write up 3 here, then x stands for 1 basically, and then we're going to have 4, then we're going to have 1 again, and then we're going to import just the number 5. And so this should give us 3x to the power of 4 plus x to the power of 3 plus 4x to the power of 2 plus just x to the power of 1, or just, which should give us just 1x, and it should also give us plus 5. So let's just run this and see what we get here. Okay, so here we got, so this is basically our equation here. So this is basically just our polynomial here. So we have 3x to the power of 4 first, then we have plus 1x to the power of 3, plus 4x to the power of 2, plus just 1x, plus just 5. So this Python code here really makes it really clear. It adds the exponent to the top, it has the plus, it also fixes these up, and it's really neat for creating our own polynomials by just inserting a few numbers which are basically just the coefficients. And with any of the coefficients, you can just add them, you can just put them here, and then it'll generate the polynomial for you. So basically this is just our first code, and now we're going to be moving on to our second Python code. So I've already got all the code here, and you guys can copy this down as well. So I'll just explain what each line of code does. So I'm just going to quickly show how our program will actually look like before starting to explain all the code. So let's just run this quickly here, and it's going to pop up a nice little window for us with our plots here. So if we saw the video from the beginning, there was some type of these type of lines here for the Missile launch. It kind of looked like this, so that's basically what we're going to be plotting here. We're going to be plotting the polynomials inside of this graph. And we can have 1, we can have 2, we can have 3, we can also have many more as you want. You just got to plot more and more. So now let's get on with our code for actually coding what we just saw there. So first we're going to be importing two libraries to help us with our plotting, and the first one is going to be importing NumPy, and this will just help us for our math. Next we're going to be importing matplotlib, and this will help us for making our grid and everything else. So we first have our x and y coordinates for our first line, and we're just going to write x equals to the np.linespace, and you can just leave this value here. This actually just helps us for our grid place. And then we're just going to be writing y equals to negative x. So basically we're just going to be writing y is equal to negative x to the power of 2 minus 2x. So this is also a binomial or a polynomial. So this will be our first line or our first plot. Next we have our second plot, which we're going to give a variable of z and a variable of q. And z is going to stay as this, the same thing as x. And then we're going to have q is equal to negative x to the power of 2 minus 2x minus 3. So this is a trinomial or also a polynomial, and this will give us our second line. So basically, if you didn't know already from our linear equations video from a long time ago, minus 3 will just bring down the first line just 3 times lower than the first line there. And now we're going to be moving on to this one. So this is our third plot, and for these should actually be renamed as these coordinates here. So let me just quickly rename those. And here we have L and N for our variables. And the reason why we're just putting different variables is for the plotting. We can just plot many different ones at the same time. Because if we just put them all as x and y, then we're gonna have to change up our code again, and then we can only plot once at a time. So by putting more variables, we're gonna be able to plot more at a single time. So we're gonna keep L the same as z and x. And then next we're just gonna be having negative x to the power of 2 minus 2x minus 6. So basically this will just make our line go down 6 spaces. So that's basically just our lines and plots there. And then all this code here is just going to help us to style a grid to make it look fancy and to make it look neat. So you can just copy this down. I'm not going to be explaining what each of these do here. And then here we're just going to be plotting all of our lines here. So we're going to be first plotting our x and y, then our z and q, and our L and N, and we're just going to be showing our grid. And also note that you can just keep on copying and pasting these same codes and then just changing these numbers up to get your own plots if you want to do it as well. So let's just run this and see how our code looks like. So here we have our 3 lines. So our first line is just this, negative x to the power of 2 minus 2x. So this is how it looks like on a graph, and this is how negative x to the power of 2 minus 2x minus 3 looks like, and this is how negative x to the power of 2 minus 2x minus 6 looks like. And feel free to change this code and experiment however you want for any of your polynomials, and you can add as many ones as you want as well. And yeah, that's basically it for this video. If this video ended up helping you out, make sure to drop a like and subscribe, because it really does take a lot of time to make these videos, and it really mean a lot to us as well. So thank you all so much for watching, and we'll see you guys in the next video.